Dear participants, very good evening to one and all. Today we have Dr. Ravi Kumar Mandava with us. He is an assistant professor in the Department of Mechanical Engineering, IIIT Kurnool, Andhra Pradesh. He holds his PhD in Robotics and Soft Computing from IIT Bhubaneswar. With over 11 years of teaching experience and 4.5 years of research experience, he worked on humanoid robots, motion planning, manipulators, ex- exoskeleton mechanisms, composite materials, and soft computing applications. He has authored numerous essay and Scopus indexed publications with a citation count of 650, H index 16, and I10 index 19. He has successfully completed multiple sponsored research projects worth of 50 lakhs, including DXT funded works such as design and development of coconut harvesting robot, calf stimulation and foot drop excessive device, tree climbing mechanism robot. He has also been granted with 6 patents and 2 published patents, showcasing his strong innovation credentials in robotics and assistive mechanisms. In addition, Dr. Mandava has served as resource person, keynote speaker, and session chair in several national and international events and organized many FDPs and workshops, including SERP-sponsored Karyashala on artificial intelligence for robotics in 2024. He is also a member of IEEE and the Robotics Society, contributing actively as a reviewer and editorial board member for reputed international from the standard publishing companies Elizabeth, Springer, and IEEE. Really, we are happy as we have Dr. Ravi Kumar Mandava with us. Thank you, sir, for accepting our request, and over to you, sir.
Thank you, Samir sir. I think my presentation is visible to you.
Yes, sir.
Yes.
Okay. Yes, you are audible and visible, sir.
Okay, thank you. Very good evening and warm welcome to you all participants. Myself, Dr. Ravi Kumar Mandava, Assistant Professor at IIIT Kurnool. Actually, I have done my PhD in robotics. Today, I am going to talk about the importance of robot in engineering applications. I think you all people know about nowadays many places people they are using robots. Okay, it is not only for industrial applications, and they are going to use in like home application, like personal application, like medical application, like agriculture application. There are numerous applications they are going to use it, and very soon we can see the complete how the human can do all the tasks, the humanoid robot also. And today my talk is I'm just going to discuss about the few introduction parts about the robot. Then I want to show few of the examples, like in what are the different type of applications the robots they're using, like in engineering applications, like you can see like in industrial, or it may be like agriculture applications, like in medical applications. Before going to talk my talk, first I want to discuss about what is robot. I think maybe few people may know about, many people they may heard about the exact meaning of the robot. Generally, when we call it as a robot, it is a reprogrammable. See, when we are going to design any robot, or when we are going to purchase the robot, when we are going to develop the robot, it could be a reprogrammable and it should be a multifunctional manipulator. See, when we are going to design any robot or maybe develop a robot, if the robot can do one task, the particular task, and sometimes what will happen, we may not require the particular task. We want to change the another task. That means we are going to do some other applications. See, then what will happen when we are going to discuss about this robot? Generally, what will happen? Whatever the manufacturing cost and when we are going to purchase or when we are going to develop, the cost of the robot should be high. That's why whenever we have purchased the robot and we are going to design the robot, it should be a multifunctional. It should be a multifunction. It can do different type of tasks, and it should be a reprogrammable. And you can see whatever the robot we are going to design, that robot it can be like it can be capable to transfer like materials, parts, and tools or specialized device through variable program motions to the performance of the variety of tasks. Coming to the history of the robot, you can see the history when the robot of the world it was started. See, the robot, the term it came from the sedge word. It is a sedge word, and initially people they call it as a robota. The meaning of the robota is nothing but it is a forced or slave labor. That means whatever the human can do, the task robot can do. And the first, it was introduced by the Karel Kepak in 1921. He is a such playwright, and how he has introduced, he is writing one drama story. In his drama story, he has used the term Rossum's universal robot. But according to his perception, when he has introduced in 1921, his perception is that a robot is a mission. It's look wise similar to human being. See, when we are going to develop the robot, it's look like a mission, but it is whatever the task we are going to do human, that can task it can be capable to do it. And the first digitally operated and programmable robot was invented by George Bevel in 1954. The name will call it as a Unimate robot. This Unimate robot, we are going to initially, they have utilized for die casting applications. I think mechanical engineering people, they may understand when we are going to do the casting operation. See, the casting product should be hot condition. It is uh, very difficult to carry as a human being by hand or something by holding. That purpose, generally, what they have done, they have used this robotic manipulator to holding the casting product, to hold the casting product. That robot they have developed, the first one is in 1954. That we call it as a Unimate robot. And you can see why the robots are required. See, generally, when we are going to think about why robots are required, why it is required, you can see the robot can build the performance capability superior to those of human being. Suppose when we are going to develop any product or any manufacturing of the any product, the capability of the superior better than the human being. Why? Because as a human being, we have some error. We can make some error, but a robot cannot do that type of error, and it can do perform simple and repetitive tasks. As a human being, the simple and repetitive task we are feeling bored, but robot cannot do the bore and all the things, and it can do consistently, and it can do the quality wise better quality it can be provided. And robots do not have any limitations and it don't have any negative attributes. And that means when we are going to do the task, robot don't have any limitations. There no need to rest, no need to take any rest. Until you have provided the battery power, it can work it. But when we are going to do the task, robot don't have any negative attributes also. And robots are used in industries here to save the time when compared to the human being. See, generally what will happen when we are going to make any product by using completely as a human being, it will take a lot of time to complete the product. Finally, the output of the product we are going to send. But when we are going to use the robot, it can be fast, better than human being. And also you can see the robots can also work in poor working conditions. Poor working conditions means like and see where the harmful gases will be there. Suppose where the industrial like chemical power plants, like thermal power plants, and where the harmful like nuclear power plants, that type of environment robot can work. But when he as a human being, if he even work in that type of environmental conditions, he may damage his health and he may die also after few months or few years. And that's why we can use this robot like any poor working conditions, and also it can be improve the working conditions and reduce the risk. See, as a human being is working in industry, there is a chance to sometimes it may be there is a chance to there is a risk, maybe there is a chance that type of risk we can reduce if we are going to introduce any robot. Like when you come to the essential characteristics of the robot, the first one you can see the sensing. And here what will happen, the robot should be, see, whatever the robot we are going to develop, the robot can be capable like these all four essential characteristics. and one is the sensing, and second one is the moment, and third one is the energy, and fourth one is the intelligence. See, when we are going to design or develop any robot, that robot can be capable to sense. Like as a human being, how we are sensing. We have our own sensors. By using our own sensors, we are going to sense it. Like you can see how we have our eyes, how we have our nose and hands. Like that, similarly, a robot can also capable to sense it. Then only the robot can be get the information from the surroundings. Then that information, according to the information, the robot can be capable to work it in the environment. Like whatever the robot we are going to develop the robot, that robot can be capable to move entire the industry environment. Like how as a human being we are walking. In the similar way, we can make some capability to move the robot in the entire industrial environment. Then what will happen? We are going to utilize the entire the complete the time of the robot, we can utilize it and it can complete the task, it can be completed. The robot can be capable to the complete task, it can be do it. For that purpose, we can make like the bottom of the robot, we can make like wheels, or it maybe we can make the walking, or like your how the legs will be there as a human being, and also we can make it like a railing movement, and it may be rollers. All these things we can provide it. Then we can make the another essential characteristic is that energy. Here what will happen, the robot needs to be able to power itself. See what will happen, how as a human being we are taking the energy. See, energy means we are taking the food and water and all, we are getting the energy. In the similar way, we can give the energy to the robot. Then what will happen, when we are going to provide the energy, then the robot can be capable to work continuously. The energy may come from, like it may be batteries, or it may be power generators, or it may be fuel. And the next one we can utilize like intelligent. See, when we have provided the sensor, the sensors what it will do, it will get the information from the surroundings, and according to the information, the controller can take the decision. But how the robot can take the decision, the robot needs to, we need to provide the intelligence. That means how as a human being we are thinking. See, as a human being, suddenly some problem will come. We are thinking how to rectify that problem. In the similar way, the robot can make an intelligence. How we are going to make an intelligence? We need to do. We need to make like we are going to provide our artificial intelligence to the your robot. Then only your robot can be become an intelligent. But how we are going to make an intelligence? We are going to provide some programming manner. We are going to make the programming. Suppose this type of situation will come. What type of decision I need to take? All the tasks we need to provide it. Then accordingly, when the robot, if any task, any problem will come, according to the situation, it can check the program and it can take the decision. Like we can see the complete robotic system, generally what will happen when they have introduced it in 1921, and their perception is that a robot, it's look like a human being, but look like human being means it's not a humanoid robot. It's just like it's similar to the how the human arm is there. See, we have our human arm, your arm, or it may be hand. We have our hand. See, our hand have like it maybe you can see like shoulder joint will be there, and you can see the like the upper limb, and there is a elbow, and there is a lower limb, and there is a your grip and wrist, and there is a gripper. In the similar way, see what it will do, our human arm, we are going to do some particular task, we are going to do some task, we are going to complete. In the similar way, the robot can also look like a human arm. See, when we are going to see the robot, the robotic system, you can see there is a base will be there. Every robotic system, it consists of there is a base and there is a joint, and you can see there is a link, and see how we call it as a limb, that we call it as a, in the mechanical point we will call it as a link, and there is another link. And see here what will happen, you can see the links are connected, it may be a serial or it may be a parallel, and at the end we are going to connect it as a, there is a end effector. You can see initially there is a base, and the second one will call it as a manipulator arm. The manipulator arm means we are going to connect number of joints and number of links we are going to connect it here serially. That we will call it as a manipulator arm. And the end effector, see, when we have human arm, we have a wrist position. In this position, what will happen? We are going to connect the end effector. The end effector, it may be, it depends upon the task, what we are going to do it and how all the joints can work it. See, as a human being, we have our own muscles. Okay, as a human being, we have our own muscles. By using our own muscles, we are going to do the particular task. But how this mechanical element, the robot is a mechanical element, how it can do? The mechanical mission or it may be element, how it can do the task. See here what we are going to do. Each joint, we are going to provide some type of actuator. That depends upon the what type of actuator you are going to attach. That depends upon the load you are going to capable to carry, the task you are going to do it. See, nowadays actually in the market you can get, there are many varieties of actuators are available. Like you can see, like it may be a mechanical actuator, or it may be electrical actuator, or it may be pneumatic actuator. There are variety of types. In the mechanical actuators are various types of mechanical actuators are there, and various types of electrical actuators are there, and various types of pneumatic actuators are there. Here, what will happen? That depends upon the purpose, the payload. Payload means the end effector of the robot, how much load it can be capable to carry. When we are going to use a gripper of the end effector, how much load it can be capable to carry. That means your robot, how much load it can be capable to carry from one location to another location. That depends upon the load. We are going to attach the actuator for each joint. That we will call it as the artificial actuators. That we will call it as the artificial actuators. See, now the task is that we have provided the base joint, we have provided the links and joints. See, each joint we have provided one actuator, but how the actuator, that means the actuator can move it. The actuator we are going to connect to your driver, then the driver we are going to connect to your controller. See here what will happen when the robot is doing particular task. The robot, it consists of some sensors. That means each link or each limb or it may be a wrist position, we are going to provide the sensor. The sensors will take the information from the surrounding. That information we are going to send to the controller. That controller will decide the task, what we need to do. Then controller will control your drive unit. That means your all actuators, it is going to control by your drive unit. Then it will do the particular task, we can perform it. Then you can see there are various types of robots are there, and generally we are going to categorize it. There are two types. One is the industrial type of robot, and second one is the mobile robot. See, basically what will happen in industrial robots, we are going to use for industrial applications. Like when you go for mobile robots, we can use like maybe like there are our household purpose we can use, like inspection applications we can use, like military applications we can use, like we can use for like societal applications we can use it. And when you come to the industrial, we are going to again categorize it. There is a two types of manipulator. One is the, see, we will call it as a serial manipulator. Why we will call it as a serial manipulator? Here you can see all the links are connected in serially. You can see in the previous picture, here all the links are connected in serially. That's why we will call it as a serial manipulator. And if the manipulator, it is moving on the 2D plane or it may be 3D plane. Okay, so if it is a 3D plane, if it is a 2D plane, if the manipulator is moving on the 2D plane, like it may be there is X and Y, and it may be rotated with respect to X or Y, that we'll call it as a serial manipulator. Or when we are going to manipulator is moving on the 3D plane, that we'll call it as a spatial manipulator. That means, see, when we are going to the, your manipulator can move in the 2D space, where the minimum degrees of freedom is required, 3 degrees of freedom, or it may be 2 linear and 1 rotation. And when the manipulator is going to move in the moving in the spatial, the minimum degrees of freedom is required for 6 degrees of freedom. And when you come to the, there is other type of manipulator that we call it as a parallel manipulator. You can see in the previous picture, all the links are connected in serial here. Here you can see, you can easily understand all the links are connected in serial. But when you come to the parallel manipulator, you can see there is upper frame and there is a lower frame. That we call it as a upper platform and lower base. See here what will happen. The links are connected. This is one link and this is another link and this is the third link, fourth. And see in the picture you may easily understand there are 6 links are there, but all the 6 links are connected parallel to each other. Like one link is parallel to another link. See here, what is the application we are going to use it? Like you have seen the serial manipulator, you are going to use like many industrial application. I can show you in the next slides. But when you come to the parallel manipulator, we can use also like industrial applications. Like when you are going to do some task. Why? Because this parallel manipulator, it consists of like 3 linear moments and 3 revolutionary. Okay, one is the 3 linear motions and 3 revolutionary motions will be there. Here, what will have the 3 linear motion, like it can move in the x along x-axis, along the y-axis, and along the z-axis, and also it can rotate along theta x with respect to x. It can rotate with respect to y. It can rotate, and with respect to z also it can rotate. The people they may can use that depends upon the what type of application they can use. And the one application I can tell you, suppose if you want to track the sun light, you can track it by using this setup. See the and also the other application, suppose we want to do the hole, we have there is a workpiece, we want to make the hole in the particular angle. See, when you are going to place your workpiece on your it may be milling machine or it may be a drilling machine, see what will happen there. There, what will happen? Your tool will be moved maybe one direction, and your workbench will be moved. But suppose if I want to rotate, I want to make a whole, it may be a particular like a theta x is some angle and theta y equal to some angle and theta z. That you want to do it, we can make your workpiece on the top of this setup, and we can tilt it your workpiece, and you can make the whole how you want to do it. And another thing is that recently the people they are using for, there is another mechanical engineering application like a farming application. Suppose when you are going to make the farming operation, if you want to make your sheets, if you want to make the sheet, if you want to bend it, how much, what type of structure you want to do it, the farming operation also we can do it. And the next one is the other category, we'll call it as a mobile robots. See here, we can call it the mobile robots. There are 2 types. One is we'll call it as a wheeled robots, and the second we will call it as a legged robots. See here, what will happen? The robot, it consists of wheels, and the other category, the robot, it consists of leg. Why these two it is required? See, the wheeled robots, it can be capable to move in the only the surface. It should be a flat. That means the wheeled robots can be capable to move only in the flat surface, and but if it is an unstructured environment, if it is structured environment, wheeled robot can be moved. If it is unstructured environment, that means it cannot be a flat. It may be some obstacles will be there, some stairs will be there, some ditches will be there. The wheeled robots, it cannot be capable to move. Then in particular type of situations, we can use for legged robots. When you go for the categorization of what are the different types of wheel robots and legged robots, in the next slides I can show you. See, then another you can see here, whatever the serial manipulator or maybe parallel manipulator, the industrial manipulator, we will call it as a stationary robots or stationary manipulators, we will call it as a. Why? Because here what will happen, the robot is putting on the stationary, and whatever the task robot want to do it, all the raw material will come to the in front of the robot by using the conveyor belt. Then robot can do the task, whatever the task robot can be capable to do it, the task it can be robot can do it. They all these 2 categories we will call it as a stationary type of robots. See, when you come to the stationary type of robots, you can see here what will happen. These robots work without changing their position. You can see here the robot cannot move from the location, and without changing their position, it can work it. See here, there are different types of varieties of robots are there. You can see the one is the first we'll call it as a Cartesian robot, like we'll call it as. See here, what will happen? The robot can be capable to move like 3 linear motions, like X, Y, Z. X, Y, Z. The three linear motions it can be capable to do it. Like you can see the other type, we will call it as a cylindrical robot. See here what will happen, this robot, the 3 linear motions means generally in the robotic, we will call it as a prismatic movement. The prismatic means through and fro motion. It can be like x-axis, one prismatic, and y-axis and the z-axis. When you come to the cylindrical robot, here one revolute joint will be there and two prismatic joints are there. The whatever the workspace we are going to generate, that we will call it as a cylindrical workspace. When you come to the Cartesian space, the whatever the workspace we are going to generate, that we will call it as a rectangular workspace or cuboidal workspace, we will call it as. And when you come to the other variety, that we'll call it as a spherical robots. Here what will happen, there are two revolute joints will be there, one prismatic joint is there, and whatever the robot, the workspace it is going to generate, that is, it will be a sphere shape of workspace it can be generated. And the fourth one, that we'll call it as a articulated robot, it should be a similar type of human. So how all are revolute joints, how the human arm can move in the same type, this robot can be capable to move it. There is another special type of robot that we will call it as a selective compliance assembly robotic arm. That will short name we will call it as a SCARA robot. This we are going to use for like assembling applications, like we are going to assembling like your chipboard or if your motherboard, all the components of electronic sets we are going to assemble by using this SCARA robot. And the other type we are going to collaborative robot. Here what will happen, human can work along with the robot. Human can move the robot by using his arm and he can be capable to work. That will call it as a human collaborative robot or collaborative robot, people may call it as. The other previous, whatever this Cartesian robot or a cylindrical robot or spherical robot, or we are going to use the articulated robots, SCARA robot, all robots, we will call it as an industrial type of robots. But this robot, we are going to call it as a collaborative robot. The other type I already discussed with you in the previous slide, that we will call it as a parallel robot or parallel manipulator. Like you can see, in industrial robot, how they can use it in industry. Like you can see the robots, how they are going to use in industrial applications.
Robots and factory automation solutions have been facilitating industrial production for over 60 years.
You can see here to manufacturing of the while assembling applications in the manufacturing environment, you can do robot can do the assembly, like it can do the pick and place operation, it can do it. Like you can see, when we will call it as an end effector, sir, every robot, industrial robot, it's required, there is an end effector. Every industrial robot is required, there is an end effector. You can see here, every industrial robot, there is an end effector. The end, then only it can be capable to do some particular tasks. The end effectors generally would call it as, there are two types. It maybe one will call it as a like a gripper, and the second one will call it as a tools. Generally, they are going to categorize two types. One is the gripper, second one. See, gripper, what it will do? The gripper, it can be capable to grasp the objects and it is holding the object from one location to another location. And tools, what it will do? It will try to do some particular, it will do to perform some particular operation. Like you are going to provide the end effector, you are going to put some welding tool, like a welding gun you are going to provide, it can do the welding operation, or we are going to do the painting brush, we are going to, it will do the painting operation, or we are going to provide like cutting, like a cutter, we are going, it will do the cutting operation. That depends upon the application, what type of tool you require, you can change your tool. And you can see here the varieties of grippers. And when you go for deeper, the grippers are also, there are different types of grippers. Like you can see the mechanical gripper, vacuum gripper, there are electromagnetic gripper, like there are varieties of adhesive gripper will be there. There are variety of grippers will be there. That depends upon the application. Like when you are going to use to hold the glass, like we are going to grasp the glass, we are going to use for like a vacuum gripper, we are going to use it. When we are going to hold the like metal parts, we are going to use for like electromagnetic gripper, we are going to use it. Like when we are going to holding like small object, we are going to use the like it may be a pneumatic gripper, or it may be a mechanical gripper, or it may be electrical gripper, we are going to utilize it. And when you come to the tools, you can see in this picture, when you are going to use for welding application, you are going to attach the welding gun. And when you are going to use to cut something, we are going to use the cutter. When you are going to do the painting operation, we are going to use the spray painting gun, we are going to attach it. See, generally what will happen in industrially, there are different type of applications they are utilizing the robots. One is the material handling applications. And the second thing is that they are going to utilize for like mission loading, unloading. Like when you see if you want to move in earlier without robots, like when you're going to use like industry 1.0 and 2.0, what will happen when you are going to shift the material from one location to another location industry? Human can be only do the task. But when you come to the industry 3.0, the computer and robots was introduced. These robots can be capable to carry the things from one location to another location. Like material handling application, we can use, like we can use the mission loading and unloading applications. See here what will happen when we are going to use like a mission loading. Say that if you are going to load the whatever the manufactured products in the, like it may be a vehicle or it may be a boxes, we can use the robots to loading and unloading. We can use the capable to load. And when you come to the assembly application, like if the robot want to do, like as I told you earlier, if you want to do some assembly application, like if you are going to fixing your door of the vehicle, or maybe you are going to do fixing of the electronics components on your board, or it may be your chip board, that also we can do it. Like you can see, there is another application we can use, like inspection application, like welding application, like spray painting applications. See, when you come to the inspection application, see, once the product was manufactured, when we are going to release the product in the outside of the industry, then what will happen? Particularly, we want to check what type of defects are there. For that purpose, what will happen, as a human, he may done the mistake. Why? Because the minute cracks he may not able to identify. Suppose the product have, there is a minute cracks and minute defects will be that human cannot be able to see. Why? Because generally, as a human being, our eyes have some error will be there. Maybe that error we are unable to identify. But if you keep, there is a one RGB camera, that 3D camera of your RGB or maybe 3D camera, you are going to attach to your robot. The robot can be capable to scan the entire part. It can be capable to scan it, and it can rotate the complete the product, and it can scan it and it can check it. Okay, what are the problems are there? What are the minute defects are there? Then accordingly it can decide whether this can be passed with the quality level, or it may be it is going to reject it. And there is a welding operation, like we can do the welding application, we can utilize it, like you can see the spray painting. Suppose you can see in the industries, so if you want to do the painting operation, if you want to do it by using your robots, we can utilize and we can do this painting operation also. Like I already told you, like material handling applications, you can see the transfer the material and one place to another place, and we can loading and unloading application. We can use the, like the serial manipulator. We can use it. Here you can see in this picture the robot in the bottom. They have provided some wheel type of mechanism. In this case, what will happen? The robot can be capable to move the entire environment of the industry, and it can place your things from one location to another location. It can be capable to, it can be moved from one location. Like if you are going to take the best example is like Amazon, the warehouse, where Amazon warehouse or Flipkart warehouse you can take. There is a many number of cartoons will be there that we are going to, as a human being, it is very difficult to capable to arrange all these things. That's why we are going to use these type of places, these type of like industrial robots. We can use that robot can be capable to move the things from whatever the boxes will be there, or it can be moved from one location to another location. Like you can see, there are different applications, as I told in the previous also, like you can see die casting application, like plastic molding application, like metal machining operations, like forging applications, like press working application. You can see in this picture, you can see how the material will be heated, how much hot condition will be there. That as a human, we cannot capable to carry. We can use by robot, we can easily capable to carry. And what are the benefits we can get it? We can get the precision, high precision we can get the accuracy we can get, and the safety. The main point is called safety, we can get it, and the speed when compared to the human, and reliability of the workpiece it can be generated, and flexibility. Whatever the changes we can do it. Why? Because the robot can do all the tasks. It can be like by programming only it can do. See, if you want to do something change in your task, you can just simply changing your program. That type of flexibility we will get it when we are going to use this robot in manufacturing applications. And you can see the like assembling applications, like you can see in this picture, like how the car they are going to manufacture it. By all the robots only, it can be fix all these things. Whatever the components require, each and every component can be fixed by, without any human being. Robot can be capable to assemble the entire the body of the vehicle. And this is the inspection I already discussed. When you are going to make any manufactured product, if you want to pass from manufacturing industry to the outside of the environment, we want to check the quality, and the inspection we can do. Here we can identify by using the 3D camera, or it may be RGB camera. We can identify it, what are the defects are there, then it can be passed, whether it will be passed or it may be whether it will be rejected. And like you can see welding applications, you have seen like a man, when you are going to compare with manual welding and robotic welding. So you try to observe it, the how very good quality and the way of welding should be a very quality and should be a very fine welding. We will get it. When you are going to use manual welding, we will get there is a lot of disturbance will be there. Why? Because human cannot do that much, the accuracy we cannot do it. And if you have time, you can check it whenever you are going to industry or maybe your institutes. You can check the difference of the welding quality between the human welding and the robotic welding, and see the benefit we can get it. The greater quality of the product, the whatever the product we have done by using robotic welding, the quality will be increased and improved safety and higher productivity. We can do many number of products in a single day, or it may be in a hour. Like you can see the spray painting applications. Like you can see when you are going to painting your vehicle, see generally what will happen, whatever the painting we are going to use, it is a chemical, completely chemical painting, and it is a harmful to the human being. That's why we no need to introduce any human being. Robot can able to do the task, and it completely robot may able to exactly which part you want to do, what type of painting, everything it can be capable to do it. See the advantage we can get by using your spray painting robot, like you can see high consistency and better productivity, and like increased labor safety and less power consumption, and we are going to use the minimize the use of paint. See the paint utilization is also, we can get it very less paint, we can utilize it, we can minimize the paint. You can see this video and how the robots can do the different types of operation, like assembly operations, like you can see like painting operation, how the robots can do it. And the finally, how the robots see the painting operation, how it can do it. You can easily, you can yeah, when you come to the generally what will happen, these robots we are going to use in industry, we will call it as a robot cell layouts. Here what will happen when we are going to use this robotic cell means it is a complete system of the robot and controller, and you can see there is a other peripherals will be there. And here what will happen, the robot cell, there are different types of classes. One is the robot centered work cell, second one is the inline robot work cell, and third one is the mobile work cell. What is this robot centered work cell? Here what will happen, robot will be there fixed in one place, and whatever the missions required to do the particular task to complete the product, okay, the raw material to the complete product, the missions we are going to place a surrounding of the robot. Then what robot can do, you can see here what robot can do. Robot can control all, maybe 3 missions or 4 missions or 5 missions, robot can control it. Like you can see there is a raw material is coming on the conveyor belt, and robot can be capable to take this raw material and it can be placed in mission 1. Like mission 1 you can consider as a like one your conventional lathe mission, or it may be a CNC lathe mission. And robot can take this raw material and it may be placed on check, and the mission can do the particular task, whatever the task it can do it. Then once the task done by the mission 1, once it is completed, and again this robot will come here and it can take the part and it can place on the mission 2. Then once the mission 2 will become, then mission 3. Like that's one single robot, it can be controlled by number of missions. Here what will happen, the robot should be a center, and all the missions we are going to place it surroundings of this robot, and the complete raw material to the final finishing product, the robot can do without any human intervention. The robot is able to manage all these missions to like maybe pick and place operation. We can pick and we can place there. But and finally, the robot is once the final product is completed, robot can pick that product and it is going to place on the conveyor belt. The final finished product, it will go to the outside of the industry. Then there is another type, we call it as the inline robot work cell. Here, what will happen? See here, robots are moving on the railing moment, and see you can see here there is a there are two robots will be there. So you can see here the robot located along the conveyor belt. Here, what will happen? There is a conveyor belt is there, and the robots are placing along the conveyor belt, and the material is moving on the top of the conveyor belt. Like you have seen in the previous videos, how the car manufacturing was going to be done in the industry. See, there also along the conveyor belts, robots are standing, like robots are stationary, and the conveyor belt is moving. And each robot, whatever the time required to do the particular task, we are going to set in the programming, and according to the task will complete, and the finished product will go to the next robot. And whatever the task can be able to do in the next robot, then once it will go to the next position. Like that, it can be do it. Like the third type, we will call it as a mobile work cell. We can see here in the mobile work cell, what will happen in the here robot is there, and along the missions, the robot is moving on the railing moment. See here what will happen. This is the input material, and there is a mission 1 and mission 2, and there is the output material. See here the robot, we are going to place the robot on the railing moment. The robot will grasping the input material, and it will place on the mission 1, and the mission 1 will be able to do it. Whatever the task it can be capable to do it can be complete. Once it is completed, and this robot can move on the railing moment, and it can collect the product and it can place on the mission 2. Finally, the robot can collect the product from the mission 2. Whatever the task can be capable to do it mission 2, and it will once it is finished, the robot can be capable to collect it, and it can place onto the conveyor belt or the output of the conveyor belt. We can see not only for like welding applications, not only for assembling applications, not only for like loading and unloading applications, not only for like painting applications. This robot nowadays they are using. There is another engineering application. People they are using like a 3D printing. Like many people, you may know about what is 3D printing. You may have seen your maybe your laboratories, the 3D printing, how it can be moved. Here you can see. See, we are going to make our own extruder. We are going to make our own extruder at the end of your robotic arm. At the end of your robotic arm, the end effector we are going to attach here. And see, this robot can also be capable to do the layer by layer deposition. Like that 3D printing, like we will call it as additive manufacturing. That layer by layer deposition we can do like polymer material, and also we can do like by using robot. See, this is the industrial type of robot, and I have shown this is a like collaborative type of robotic arm. This is a collaborative type of robotic arm, and we can do like in the previous slide I have shown like we are going to use the polymer material, but also we can use like metal. Also we can do it like we have used here wire. We have used here wire, that we will call it as a robotic wire arc additive manufacturing, WAM. We will call it as a WAM. And we can do like the layer by layer deposition. We can do welding operation also. We can do by using this robot. See, this is the robot we have purchased, IIITM Karnool. One of my PhD student is working. The layer by layer deposition, how the robot can be capable to do the layer by layer deposition. See how the people we are going to do like by using like polymer material, the layer by layer deposition, and there we are going to make some components. Whatever the components we require, whatever the projects we are going to do it, the components we are making by using the polymer. In the similar way, whatever the components we require like a metal type, we can do by using this wire arc additive manufacturing. And you can see this video. And we this welding control have all the like whatever the depends upon the material. We can change the current, and we can change the voltage, and we can change the speed and the speed of the robot. Everything we can change it here. And what type of angle, the torch angle, what type of angle we require, the torch angle also we can control it. That we can do it. And as I said, up to now, what I discussed, all these applications related to industrial applications. Then we move to the other societal application, like inspection applications, like we can use like military applications. Like you can see, there is other type of robots. Like one is the stationary robots, and the other one you will call it as a mobile robots. The mobile robots, as I said, there are two type of categories. One is the wheel robot, second one is the legged robot. See here, wheel robots, the bottom of the robot, it consists of wheels, and based upon the wheels only, the robot can be capable to move from one location to another location. See, but as I said in the previous case, these robots can be capable to move only when the terrain condition should be a flat. When the terrain condition, it should be a not flat, it is very difficult to move. But the researchers, they have tried, there are different types of wheel robots. Like you can see the first type, like single wheel robot, or we'll call it as a ball type of robot. And the second, see, the problem is that we can see the single wheel and two wheel type of robot, the balancing is very difficult. And people, they are trying to, by using our gyro and by using accelerometer, they are trying to balancing this the robot. And like you can see, they are going to use, there are different types of inspection applications where human cannot be capable to move. In particular type of application, we can send this robot, we can capture the images, and what is going to be happen, we can get the images. Based on the image, we can take the decision. Like we will call it as the another type is called two-wheel robot, or we will call it as a Segway robot. We will call it as, and this is the another type of robot. And there is another robot, like you can call it as a three-wheel robot, like how the auto rickshaw will be there, like similar type of three-wheel robot. Like you can see, people, they are working in like four-wheel robots, like multi-wheel robots, like tracker robots. That depends upon the application where they want to utilize it. The each researcher, they what they depends upon their application. They have slowly, they have developed, there are variety of configurations of the wheel robots. Like you can see the tracker type of robot. This tracker type of robot, it can be capable to uneven terrain to move. It can be capable to move on the uneven terrains. Like it may be, like as I said, wheel robots, it cannot be capable to move in uneven terrain, but tracker type, it can be capable to move in uneven terrains. Like you can see the other varieties, like you can see that one is the legged robot. Here the legged robots are mobile robots. It is similar to the wheel robots. And here what will happen, the locomotion we see, we are going to make, instead of wheel, we are going to make the legged. Instead of wheel, we are going to make the legged type of locomotion, we can make it. 1 minute. You can see here, there are varieties of legged type of robots are there. That is one-legged robot, like two-legged robot. The two-legged robot, will call it as a bipedal robot or humanoid robot. Like three-legged robot. See, there is a big challenge of two-legged robot and three-legged robot. These 3 and 4 and 6-legged robots, it can be capable to maintain the balancing, but the two-legged robot, it cannot be capable to move the balancing. See, as a human being, just take the example of a kid. See, when the kid was born, after 1 year he is able to stand, and after 1.5 years he is able to walk. When he is going to start his walking, he is always going to fall down. See, because of the reason is that his center of gravity is going to out of his foot. Okay. When it is going to out of the foot, then what will happen is trying to fall down. In the similar way, the bipedal robot also, when we are going to do the research in the bipedal robot, we are going to send the center of gravity, we are going to push it, we are going to try to push the center of gravity inside the foot, then only it can be able to, it will be make the stability. And similarly, we can use like a three-legged robot, like you can see the quadruped robots, people may call it as a four-legged robot, and there is a six-legged robot, or we'll call it as a hexapod robot, we'll call it as, like you can see, like a robot with many legs. Like there is other type of robots we can see. If the people slowly they have started, they want to mimic like a fish type of robot. Then robotic fish, they want to make this type of robot. They want to leave the underwater. They want to see what type of environment is there in the underwater, and what type of minerals are there, what type of fishes are there, and what type of aquatic system will be there. All these things. And people, they have developed like flying robot, and like how the bird will be there. People, they have developed like ball type, like rolling robotic balls, like ball type of robot. And there is a other special type of robot, like we call it as a swarm robots. See, in the swarm robots means the robot configuration should be same, all robot configuration should be same. But in this case, what will happen? One robot coordinating with the another robot. How, when we are going to see how the human being, when the human being are working in the same environment, how the one human being, like you can, best example you can take like a football match or cricket match, how the one team, the people, the complete team is coordinating to. In the similar way, here robots will also coordinating. One robot will coordinate with the other robot and how to complete the task, whatever the task we have given, to complete the task, and without hitting one robot to another robot, and it can be capable to do the task. In a similar way, the other type of robots is called modular robots. Here, what will happen? In the swarm robots, all the robots, the configuration of the robot should be same. But when you come to the module robots, the configuration should be different. Each robot have different configuration, but it can be capable to coordinate with one robot, coordinate with the another robot. Like as I discussed, the other application, like agriculture application. See, nowadays actually what will happen? We are the farmers, they are facing the problem with the shortage of labor, and they are unable to cultivate the agriculture, cultivate their field. Okay, because the reason is that they are unable. There is a lot of shortage of labor, and people, they don't want to do cultivate it. And why? Because they are not getting better profits. For the purpose to overcome these problems, actually nowadays, actually you can see in the abroad already they have started. They are introduced the robots into the agriculture. Like you may have seen in India also, they have already started the robots. They have introduced slowly. They have introduced, like one best example is that, like recently we have seen like the how the drone is like revolutionizing in the agriculture field, like pesticides spraying. And like we may have seen like how the autonomous tractors are already introduced. Like one of the company was manufactured in Hyderabad, autonomous tractor. It can be capable to do all the tasks in the agriculture field. Like in the similar way, the robots are like, you can see the manipulator. We can use like to pluck the fruit or pluck the vegetables. But how this robot can be capable to pluck it, whether the fruit was ready or not, how the robot can do. Like the robot can be capable to do all these tasks by using the image processing only. It can be capable to do it. See, the robot can already do, there is an image processing algorithm. According to the image processing algorithm, it can be capable to do whether it is the vegetable it is ready to pluck, or it may be when the fruit is ready to pluck or not. Like you can see the healthcare application, like you can do the medical operations, like you may have heard about like robotic surgery, like changing the knees. People, they are using like these robots to change without to reduce the pain of the patient, because the reason is that, see, when the human can cut your skin to do some particular operation, like the few of the operations like heart surgery, like when you go for like lungs, or when you're going to do the like knee surgeries, the doctor, they want to cut your skin to without to avoid these type of problems, and cutting the skin and with the accurate, and without they no need require more cutting. Okay, they are going to introduce these robotic missions, these robotic medical robots. And what they happen, this robot can be exactly whatever the task we are going to give it, it can do very precision manner, it can be capable to do it. And nowadays, actually, what will happen, there is another type of robot that we'll call it the exoskeletons. Suppose as a human being, he is unable to carry, like best example, you can take it like soldiers, when they are going to walk on like hilly areas, like in the borders, like you can think about like Ladakh, like Jammu and Kashmir. In these areas, they want to carry their, when we're going to do some particular task, they want to carry the complete food and all the things, they want to take care of them. To take care of this, they are unable to carry. Why? Because the weight of the bags and all those should be too much. To overcome these problems, actually, now people, they are going to they are already started. They are developing like exoskeleton mechanisms. See, when we are going to wear this exoskeleton mechanism, and whatever the load we are going to bear it, that load, the structure can be capable to carry. then the soldier he cannot feel he's carrying like 50 kg, 100 kg load in the hilly terrain areas. And there is another advantage in the healthcare applications. Suppose the doctor is somewhere and patient is here, and if it is a robot is here, doctor can be capable to operate the robot from their own location, and the patient, the doctor can do the surgery and from different places also. And recent, we can see these robots slowly. People they have introduced like your home applications, like your kitchen applications, like to prepare your food. Okay, what are the dishes you require according to the your menu? The robot can be capable to do the dishes also. And you can see the service robots. You can see if you go for like banking or it will be mass. These robots you can see easily in the banking. These robots it can be guide the persons where you want to do and whatever the task whom you want to meet it. And when you go for like a big shopping malls where you want to go, and robot can be guided. And you can see like you may have seen in the hotels also, like robots they are using for servicing, like food serving applications. People they are going to use it, like the food from one location to another location. How the robots can be capable to, instead of human being, these robots can serve the food to the customers. Like you can see the people they have started like household application to clean the home, like domestic applications, like cleaning the robot in home. Like this robots can be capable to clean better than human being. And like you can see like how the robotic vacuum cleaner can nowadays, I think we are getting the less cost and many people they are using. And when you come to the military applications, you can see there are varieties of application. We can use the robots like a robot sapper, like drones, and you can see underwater like robot tank, robot truck. There are many applications. People they are going to use it. Like when you come to the space, and these robots they can be capable to use in the space applications. Like when you're going to do, when you're going to send any satellite, they will send their rovers, and these robots can be go there, and it can capture the images, and it can move in the surface, and it can be capture the images, and it can send the images to the your ground. And according to the images, we can analyze it, what type of environment is there, what type of minerals are there, whether human can be survive or not. We can, and also we can use robots for hobby applications like competitions, like students and kids they are going to participate. And there is another applications. These robots they are going to use it like another application, like physically challenged people, like people those who lost their hands, and people those who are like physically challenged people, like those who are like paralysis people, the people those are suffering from paralysis. This robot can be helped to serve the food and serve the water, and they are going to capable to do some particular tasks also. Like you can see the first picture, the person she is facing the problem with like a paralysis. And this robot, when we are going to use it, is a serial type of robot. This robot we are going to use for like can take care of that woman, to give the water, food, and all the things. And the second picture you can see the person those who lost the limb of the his arm, and he is also facing the paralysis, and the robot can be capable to give the food. And the third picture he lost his limb, and they are going to use like robotic arm. He is able to do some particular task. And the fourth picture you can see the person he don't have the limb, but he is going to attach, he is going to wear that robotic limb like exoskeleton type he was wear. And according to his muscle sensor, by using muscle movement, the person can be capable to use these artificial fingers. He can be capable to do by using these artificial fingers, and he is holding the bottle, he is holding the water, taking the food and all the things. Like people, they have started slowly to work on the biorobotics. Like you can see, the first picture is showing like a pigeon in the like snake, like a spider, like dog, earthworm, like bionic limbs, like grasshopper, like fish. As I told in the previous, I have shown you, like people they have started to develop the to mimic the biological things. Why they are going to what the target is that they want to make like the biological nature of the whatever the animals or birds or human beings. They want to try to mimic it, and they want to make the robot. whatever the task we are going to do by using birds, whatever the task we are going to use by dog, whatever the task we are going to done by human being, that task we are going to capable to do it by using these robots. That's why people they are going to now people they have started to develop the bio robots, and you can see there are different types of bio robotics like robot dragonfly, like real dragonfly, robot panther, like robot crab, like robot snake. See why this biorobotics is better than robotics. You can see biorobotics can think due to presence of their own brain, which is not possible in case of general robotics. See, we are going to develop the thinking nature of this biorobotics, how this dragonfly is thinking, how the panther is thinking, like that we are going to provide the intelligence. Then, see, normal robot it cannot be capable to do it. See, biorobotics can tackle the situation better than humans because their brain is more faster. See here, what will happen? We are when we are going to develop the biorobots, it can be capable to do. It can be take the decision immediately better than human beings, and that's why people they have started to work on the biorobotics. And here I am going to show few of the biorobotics developed students. You can see here, like this is the one type of biorobot that we call it as a snake robot. You can see here like how the robot it is similar to how the snake is moving in a similar type of structure. And there is another type I want to show that we will call it as a like a bird flying robot. Yeah, this is the like a bird flying robot, and they may call it as a flapping wings a flight simulator. And here you can see they have tested on the like platform how the bird can flapping the wings and tail in a similar way. There is a platform was developed. Like you can see, there is another type. This will call it earthworm type robot. How your earthworm can move in the similar type of configuration. This will call it as an unmanned aerial vehicle. If it is unstructured environment, then it can be capable to move. This type of vehicle can be capable to move unstructured environment also. You can see in the picture, in the video, there is completely unstructured environment. And this is the another type like a two-wheel robot that we'll call it as a Segway robot. And you can see here the how the robot is balancing when it is sloping surface. Yeah, after certain slope, it may fall down. And see, this is the one mechanism we was developed. This is completely tree climbing mechanism. See, this mechanism it can be capable to climb the tree until like canopy until canopy it can go. And by using some frictional forces, we have developed this mechanism to climb the tree, and you can see how it can be moved. This is the another mechanism we have developed for coconut climbing and cutting mechanism. And you can see how the actually nowadays actually farmers they are facing with this harvesting the coconut. To cut the coconuts, we have made one mechanism, and there is a manipulator also. And as I said, the end effector we are going to attach according to the type of what type of task we are going to do. Here we have provided like a cutter. Why? Because we want to cut the coconut. And see, this is the one more work, as I said in the previous case, like there is a mobile robots. There are two types. One is the wheeled robots and legged robots. See, in the legged robots, again I said like two-wheel robot, two-legged robot, three-legged robot, four-legged. See, this is the one work we have done to like a two-legged robot. That will call it as a humanoid robot or bipedal robot, and how the robot can be capable to walk on the flat surface, and you can see how the robot can be capable to move. And you can see the problem is that here balancing is more problem. We have to take care of the balancing. See, when the robot is walking on a flat surface, it can be balanceable. But when the robot is moving on the ascending the slope, that balancing we have to take care. And you can see here when the robot is descending the sloping surface, and you can see when the robot is ascending the staircase, and you can see here when the robot is descending the staircase. And very small robots we have to take care of it. In the similar way, as I discussed in the previously, see as a kid how he is able to fall down. Okay, and we have trained him to balancing. In the similar way, here also we have to do all the training and all the things. Then your robot can be capable to balancing. That means training means we have to send the center of gravity. See, here the center of gravity, we are going to push it inside the foot. See, if you have center of gravity inside the foot, then your robot can be balanced. Actually, this we have done 18 degrees of freedom bipod robot. In this case, what will happen? We have considered each leg consists of 6 degrees of freedom, and there are two legs and total 20 degrees of freedom. And each arm we have considered like 3 degrees of freedom. Total two arms like 6 degrees of freedom. The total. See, in the next case, what we have done this case, what will happen? As I said, each leg consists of 6 degrees of freedom, but we have considered 3 degrees of freedom at hip and 1 degrees of freedom in the knee joint and 2 degrees of freedom in the ankle joint. But when it comes to the next case, what we have done, the hip we have reduced 1 degrees of freedom. In the hip, we have instead of 3 degrees of freedom, in the hip we have only 2 degrees of freedom. Because the reason is that we don't want to do the roll movement, like only pitch and arm movement only we are able to do it. That pitch and arm movement, for that purpose we have made only 2. That there is no roll movement. That's why in the next configuration we have modified and we made like 16 degrees of freedom. And you can see how the robot can be made it. Like you can see we have mentioned each actuator like 1, 2, 3, 4, 5. That means each leg it consists of 5 degrees of freedom, then total 10 degrees of freedom, and each arm it consists of 3 degrees of freedom. See here what will happen in the robotics when you are going to do this type of task. The kinematics is the most important. You want to do complete the kinematics like forward kinematics and inverse kinematics. And if you want to do the forward kinematics, first you need to determine your DH parameter, and then your DH parameters you have to insert into your homogeneous transformation matrix. Once you have done, you will get the final position and orientation matrix. We can get it. Then similar way we need to do the inverse kinematics operation. Why? Because you need to calculate your joint angles. Why? Because when the robot is moving, you need to calculate what is the next joint angle. You have to calculate it. For that purpose, you have to do the inverse kinematics. In the similar way, you need to do like dynamics also. Why? Because we need to estimate the torque required for each joint of the robot. How much torque required for each joint of the robot, that we need to estimate. Once we know the torque of each joint, we are able to estimate the each joint of the torque. Then easily we can calculate what is the power requirement for each joint of the robotic arm. That power also we can estimate it. But because our main target is that your robot should be stable and it can be capable to do all the tasks, and at the same time it can be minimize the power also. It can be minimize the power also. And this is the work done by my student, and he has done two cases. Like one is the you can take like a ditch crossing and obstacle crossing. The two, see when the robot is going to crossing the ditch and when the robot is going to do the crossing the obstacle. Like there is another work one of my student is working. Like we are going to develop the autonomous quadruped robot, like autonomous four-legged robot. Our target is that you may heard about robotic mole. I think Indian Army, they are using robotic moles to carry the luggage in the hill areas. Nowadays, what will happen? These robotic moles are disappearing, and they want to use this robotic mole. They want to utilize it. That we will call it as a quadruped robot. For the purpose, one of my students, we are going to develop like autonomous quadruped robot, and you can see we have developed small quadruped robot. It can be capable to walk in flat terrain. Like we can see this type of robot we can use. There is a many applications like inspection applications we can use, like surveying applications we can use it, and there are different types of applications. This robot we are able to do like walking and running, and we want to do jumping, and this robot can be go there and it can see identify the environment.
Speed response. Angle speed based. Left side bus speed is regular.
Like you can see, these are the publications we have published in the field of robotics. And this is about the IIITDM Kurnool. And IIITDM Kurnool, it was announced Government of India in 2014, but it was started from 2015. And the total number of faculty regular, we are working on 50 members, and we have few ad hoc faculty also. And we have different courses like in BTech in computer science, BTech in artificial intelligence, and BTech in electronics, and BTech in mechanical engineering. I am belongs to mechanical engineering. I was focused BTech in mechanical engineering. We have 90 seats, and we have one MTech program that is robotics and automation, and one more MTech program also we have started, that is smart manufacturing. And we are also offering PhD in the field of like mechanical field, whatever it may be, a design, thermal, and manufacturing in robotics. In industrial engineering we have started, and we are also offering internship program in offline and online mode, like during winter vacation and summer vacation. Thank you. If you may have any doubt, you can discuss now. Now open to you people, please.
Thank you, Ravi Kumar sir. It was really a wonderful presentation with all supportive videos, and they are really self-explainable.
Thank you, sir.
Thank you very much. Now, dear participants, any doubts? Sir, from the participant side, what may be the approximate cost to build a 3D of robot, sir?
What is the
Approximate cost to build a 3D of robot?
the 3 degrees of freedom robot? If they want to build it, like it is a serial manipulator, that depends what type of motor they want to use it. The actuator, if they want to use servo motor or like stepper motor, we can make like it may be a 10,000 also we can make it. We can make 5,000 also. But the payload also we have to take care of that. How much payload we are capable to carry it. It may be grams or it may be kilos. That depends. The exact cost we cannot make. That depends upon the payload. That depends upon the payload. We can change our actuator.
Any other questions?
Sir, you said for students you're offering internship, right?
Yes, madam.
So is it necessary to attend any course prior to that?
That means robotics course is compulsory, you are asking, madam?
Yeah,
No, actually nowadays actually the students they can learn from internet. It's not
yeah,
compulsory.
yeah, yeah.
It's not
Okay.
compulsory. That depends upon the problem. They can sit here and they can learn. But if they can come here, summer internship they can get more time. But winter internship it is very less time. Sometimes they may stay here
Hmm.
15 days, and 15 days is very difficult. They cannot do anything.
Yeah.
Yes,
Okay.
ma'am. Thank you.
Thank you, sir. It was very nice presentation. Thank you.
Thank you. Thank you, madam. Okay, Samir sir, thank you.
Thank you very much, sir.
Thank you.
On
Thank
behalf
you.
of this ATAL FDP, all the participants, I really thank you very much for sparing time with us, sir. Thank you.
Thank you. Thank you. Thank you.
Dear participants, we will meet again at 7:30 p.m. Thank you.